let's do, given block diagram, what is the transfer function? What is a transfer function? Transfer function is an output divided by an input. And it's going to be h of s is an output over an input. The output is going to be y of s. Input is going to be r of s. In and out. So now we need to clean up this block diagram to be able to describe in our transfer function what's happening through here and with this feedback loop. So, a couple of rules. When blocks are in series, you multiply them. When blocks are in parallel, you add them. So, here's one. G2 is in parallel with G3. Let's make a note of that. That the new block, I'm going to call G2, 3, G2, 3 is equal to G2, G3. Now, I'm going to say that G2, G3 is in series with G1. So I'm just going to call that G. That's going to be G1 times G2, G3. So now this whole thing has become G. Now look at the bottom. H1, H2. I can call that H. And I'm going to say H. Actually, no, let's not call it H. No, yeah, we'll call it H. No, H is bad because we have H over here. Let's do a quick change here. Let's do quick variable change. We'll do M. So this is just going to be M. M1, M2. This is going to be M. M is equal to M1, M2. So if I were to redraw this block diagram, make this a little simpler for myself, I would say I have Rs, and it's going into my feedback loop here. It's coming out, exiting as Y. And I said that the pink one occupies the whole thing, that's G. And I said that M occupies the bottom, so that's M. And what am I running here? I'm running a negative feedback loop. And standard form for our negative feedback loop is going to be feed forward divided by 1 plus feed forward times feed backward. Here is the general form of my transfer function. Now let's say you were actually given plant values there, where like, let's just do one for an example. Let's say that M1 was equal to S plus 4 divided by S plus 2. And M2 was equal to 1 over S. In that case, then, M would be equal to S plus 4 divided by S times S plus 2 times 1 over S, which would be equal to S plus 4 divided by S squared S plus 2. So now M would go here, which means M would come back here. And you would also have an expression for G. If you were given other forms of G, you could end up with a big, long expression for your transfer function, but this is the general form here. For a negative feedback loop, you need to simplify the block diagram into something that's easily readable. And then you're going to say, here's feed forward, here's feedback. It's going to be feed forward divided by 1 plus feed forward times feedback.